Good afternoon. I'm Mr. Ekiror Pinto, a teacher of mathematics and geography. Today, I'm going to introduce to you our second topic, which is folding. Before we proceed, these are some of our objectives you need to achieve at the end of this lesson. Number one is to define folding. Number two, you should be able to explain parts of a fold. And number three, be in a position to explain different types of a fold. Let's now start by the definition. Folding refers to the process by which crustal rocks are distorted by compressional forces by being caused to bend upwards and downwards. I have said folding simply refers to the process by which crustal rocks are distorted by compressional forces by being caused to bend upwards and downwards. Are we together? Understood? Okay. We can proceed to parts of a fold. Parts of a fold. We have anticlines. This is the anticlines, this one. Have you seen? This part is an anticline. Anticline or upfolds, these are parts of the earth surface which bend upwards when folding occurs. It means when folding occurs, the part that bends upwards during this process is the one that refers to as anticlines or upfolds. Understood? Okay. Second part is synclines or downfolds. Synclines or downfolds. This is the syncline. It is indicated in the diagram. You can see this is the syncline. These are the parts of the earth surface which bend downwards when folding occurs. This one bend downwards when the process of folding occurs. This is, have you seen? This one has bent downwards. Number three is the crest. This is the crest. This part is the crest. It simply means the uppermost part of an anticline, the uppermost part of an anticline, or the topmost part of an anticline is what it refers to as a crest. Understood? Understood, students? If you have a question, you can raise. Okay. Another part is a trough. Trough. This is the trough, this one. This part is the one that refers to us as a trough. Let's see what is meant by trough. This is the lowest part of a syncline. The lowest part of a syncline. This part, the lowest part of a syncline is what it refers to us as a trough. Let's see now a limb. Limb simply means the rock layer sloping on both sides of a fold. The rock layers sloping on both sides of a fold. The rock layers sloping on both sides of a fold. It's what refers to us as a limb. This part, this one that slopes in gentle slopes, is what it refers to us as a limb. The rock layer, the rock layers sloping on both sides of a fold. It's what it is what it refers to us as a limb. Let's see now axis. Axis simply means imaginary line drawn vertically through the center of an anticline. Imaginary line drawn vertically through the center of an anticline. This part, this one is this is the axis. It is an imaginary line drawn through the center of an anticline. Understood, student up there? If there is a point you need to be clear, if there is a part you need to be clarified, you can raise up your hand so that no one complains later. Are we together? Okay, if there is no question, we can proceed to subtopic, which is types of faults. Let's see now as a folding. Folding process has resulted to different types of faults. Number one is simple symmetrical faults. Simple symmetrical faults. Let's first of all highlight them before we look each and every one in detailed form. And number one is simple symmetrical faults. And number two is asymmetrical faults. Number three is over faults. Number four is isoclinical faults. Number five is recumbent faults. Number six is nep or overthrust faults. Number seven is anticlinorium and synclinorium complex. Anticlinorium and synclinorium complex. Let's now see, let's now start look one after the other. Now let's start by simple symmetrical faults. Simple symmetrical fault. It is formed by two compressional forces of equal magnitude. Two compressional forces of equal magnitude. Two compressional forces of equal magnitude. Have you seen? This part is the same as this part. So it means compressional forces on this side is the same forces with is the same force that of the same magnitude on this side also. So the force on this side is the same with the force on this side. That is why it is being called simple symmetrical fault. Simple symmetrical faults. Understood, student up there? Okay, this is our first. This is our first type of fault. Let's see now the second type of fault. Let's see now see the second type of fault, which is asymmetric fault. Let's see what is meant by asymmetric fault. Let's see what is meant by asymmetric fault. Asymmetric faults simply it is formed by two compressional forces of an equal magnitude in which one is stronger than the other. So have you seen the difference between this and symmetric fault is that this one is formed by two compressional forces of an equal magnitude in which one is stronger than the other. So for our case, this side the force on this side has a stronger magnitude than the force on this side. Have you seen? So this part has greater magnitude than this one. That qualifies, which qualifies our second, type of fault, which is asymmetrical fault. Understood up to there, students? Do you have a question you can raise? Question, student? Okay, let's see now our third type of fault, which is over fault. This type of fault is a type of fault in which anticline of one fold is pushed over the limb of the other. This one anticline of one fold is pushed over the limb of the other fold. Have you seen at this part? One fold, this part, one fold is pushed over the limb of the other fold, this part. Have you seen? So it means this part that that has been pushed by one, this part has been pushed by one fold which has a greater magnitude or a greater force. This is now our over folds. Up there, is there any question? Kindly, you can raise up your hand. You can raise up your hand before we proceed. Let's see now our fourth type of fold, which is isoclinal folds. This is type of fold which are closely packed together and with limbs almost parallel to each other. Have you seen this part? Limbs prior to folding, these are sedimentary rocks because they are stratified. And then after folding, you can see this image has a parallel limbs. So, and they are closely packed together. So it means now our fold is composed of closely packed limbs almost parallel to each other. Vertical isoclinal folds are formed by compressional forces of equal magnitude, while inclined isoclinal folds are formed by forces of an equal magnitude. Understood, students, up there? Up there, you have understood? Okay, if you have understood, students, an assignment of today is, I would like you to research on this type of folds, which is recumbent, nep, anticlinal, and synclinal complex. Anticlinal and synclinal complex folds. So in our next class, I will start by looking these recumbent folds, nep or overthrust folds, anticlinal and synclinal folds, and synclinal complex folds. So make sure you do it. It's part of your assignment, and I will start by them. I will start from there in our next class. If you have a question, you can raise up before I call off our class today. So if there is no question, I want to wish you a nice day. Take care of yourselves because the atmosphere is not safe outside there. You can dismiss. Have a nice day.